Alright guys, in this video we're going to look at the introduction to acids, bases, and salts, and this video is on naming acids and bases, so that's what we're after here. So let's jump right in. We're going to talk more about this Arrhenius theory after Svante Arrhenius, one of the first people to study acids and bases in the next video when we actually get into acids themselves and bases themselves. But to kind of start out, we need to figure out how to name an acid. So we're going to start with the simplest acids, which are called binary acids. And binary means two, right? So it's really important that you're able to identify two elements in an acid. Now, acids are going to start with hydrogen, always. Their formula is going to be H and then some non-metal, all right? And if we have a binary acid, we're going to have H something. That's it. When we name those, we give it the prefix hydro, and we change the ending to ic, I-C. So let's try a couple of these. HCl. All right, is this a binary acid? It has three letters. Well, yeah. I know that hydrogen is H, so I have hydrogen right there. And because I see hydrogen out front, I'm thinking, oh, acid. And then I have chlorine. So I have a binary acid, two elements. So I know my prefix is hydro, and chlorine is going to become chloric. So hydrochloric acid. Now, this is how you name the formula if you're given the formula. If you're given the name and you need to work the other way, if you see the prefix hydro and the ending IC, then you know, hey, I'm talking about a binary acid here, and I just need to cross my charges in order to make sure that my formula is right. Let's look at HBr. I have a binary compound. I have hydrogen out front. That should alert me, hey, I'm looking at an acid. So this would be hydrobromic acid. Let's say we wanted to look at hydroiodic acid. All right, because I see hydro out front and the ending IC, I know it's binary. So I know it's going to start with hydrogen, which is a plus one charge, right? It's over there in group 1 on the far left side of the periodic table. And iodic comes from iodine. Iodine is a halogen. It's a -1 charge. So I cross my charges just like every other ionic compound. And I have HI. And there we go. That's how I'm going to come up with the formula from the name or name from the formula. Let's do a little harder one. Let's say hydrosulfuric acid. All right, again, I see hydro, I see ic, so that tells me I have a binary acid. Sulfuric must have come from sulfate, or not sulfate, sorry, sulfur, the element sulfur, because it's a binary compound. So hydrogen is again +1. Sulfur is a chalcogen, so it's -2. So the formula would be H2S. That is hydrosulfuric acid. So that's how I name binary compounds. Pretty simple stuff. There are acids that are called oxy acids, which are non-binary. They don't have two elements. They have more than two elements. And we call them oxy acids because one of those elements is going to be an oxygen. So when we look at these are going to be a hydrogen out front, and they're going to be combined with one of the polyatomic ions. Now, there are lots of polyatomic ions. I know you guys have memorized 6 of them at this point. So you should know phosphate, PO4 3, sulfate, which is SO4 2 negative, carbonate, CO3 2, nitrate. Oh, what are we doing here? Writing the word, not the formula, apparently. Let's get rid of that. Sorry. Nitrate, which is NO3 -1, ammonium, which is NH4 +1, and hydroxide, which is OH -1. So I know back when we did naming, I said, hey, these 6 polyatomic ions you need to memorize. So I know that we know 6, There are a bunch more. You can see some of them on page 221. There's some in my reference materials in Google Classroom. There's a big chart. When you put the polyatomic ions in there and they have that oxygen, you end up with an oxy acid. Now, here's the difference in how we name them. There's no prefix. You don't use hydro. And then we have to look at the anion itself, that polyatomic anion. If it ends in ate, so like nitrate, then we change the ending to ic. If we have an anion that ends in ite, then we change the name of the acid to OUS. So nitrate becomes nitric acid when we have a hydrogen out front. If we had nitrite, which would be NO2 minus 1 instead of NO3, then we would have nitrous acid. And so that's what the ending tells us. Now this can give us some interesting names like acetous acid, which is fun to try to say, right? So don't be surprised if you see some funny looking ones there. But let's try some of these. So we have SO4 2 negative. So if I want to make an acid, I need to put my hydrogen out front, right? We know hydrogen is +1. We have SO4 minus 2. So we're going to cross the charges. We have 1 sulfate. We have 2 hydrogens. So the formula for this would be H2SO4. Now we know that SO4 2 minus is sulfate. And so this is an oxy acid, so we don't have hydro out front. And 8 is going to become ic. So this would be sulfuric acid. All right, NO3 minus 1. We have a -1 charge. We know hydrogen has a +1 charge, so we know when we cross those charges, we're going to get 1s as both of our subscripts. So HNO3 is our acid. Nitrate, well, we have 8 again on a polyatomic ion. We know that 8 becomes ic, so nitric acid. Now, the difference between nitrate and nitrite is 1 oxygen. The ending ite means 1 less oxygen than 8 on a polyatomic ion. So NO2 minus 1 still going to be HNO2, right? Because when we cross our charges for both of these, NO3 minus, right? 1 and 1. Same thing here. H plus 1, NO2 minus 1. So 1 comes down, 1 comes down. But nitrite, ite as an ending, goes to OUS. So this would be nitrous acid. All right, you try this one. Take a minute, cross the charges, come up with the formula, all right, and then come up with a name. I'll start working it as you think about it. So our formula will be H2CO3. We know that CO3 2 negative is carbonate, and we know that 8 becomes ic, so this would be carbonic acid. So that's how we name stuff. All right, now let's look at bases. And you're really going to like this because with bases, you just name the base like you normally would any other like ionic compound. And it's going to have the word hydroxide in it if it's an Arrhenius base. So let's see what I'm talking about here. HF, all right, do we have an acid or a base? Well, we start with an H, so we have an acid. It's binary. It's not an oxy acid, so we know it's got hydro. Fluorine is going to become fluoric. So hydrofluoric acid. Okay, we've already done this one, but we'll walk through it too. H2S. So I have an H and an S, so it's binary. So it's going to start with hydro. Sulfur is going to become sulfuric. So hydrosulfuric acid. All right, number 3. Right away I see I've got an oxy acid. So I know I'm not going to have hydro. SO3 is not one of the polyatomic ions we memorized, but we did memorize SO4. We know SO4 is sulfate, so SO3 must be sulfite. We know that ite becomes OUS, so this is sulfurous acid. All right, NaOH. Okay, pump the brakes. We don't have an H out front, so we know we don't have an acid. If we see OH at the end, that's going to be an Arrhenius base, and you'll see more about that in the next video. But for right now, just know this. If you see OH at the end of a compound, assume it is a base. And when we name it, we don't say, blah, blah, blah base, like we do blah, blah, blah acid. Instead, we just name the compound. So this is sodium hydroxide. I use the regular rules that I learned when we did naming. So naming bases doesn't change anything about how to name stuff. I name the metal, and then I name the polyatomic ion. So sodium hydroxide. Here's another one. All right, now alert yourself. Iron is a transition metal, which means the name must have a Roman numeral to tell you the charge on the metal. I know that right here there's a 1, and so if I uncross the charge, just like we did back when we did naming, well, is this the right charge for hydroxide? Well, yeah, because we memorized it, right? OH minus 1. So if that's the right charge, this must be the right charge for iron. So I would say iron 3 hydroxide. And there we go. So again, we're just naming it. That would be a stock system naming question. So we're naming it just like we did back when we did the naming unit. All right, let's go the other way. Let's take our name and write a formula. So we have calcium hydroxide. All right, so we have a metal. Calcium is a metal. And we have a non-metal ion. Why do I think it's non-metal? Well, I know that OH is minus 1. And so since it's a polyatomic ion, we know, hey, it's got a negative charge. We treat it like a non-metal. So if I'm putting a metal and a non-metal together, then I need to do the cross-charge method. So calcium is in group 2. Hydroxide is minus 1. So I need to bring the negative 1 down here, drop the charge, bring the 2 down there, drop the charge. Now, be careful. I don't want Ca and then O and 2 H's. I don't want OH2. I need to keep hydroxide as a group. So when I write this formula, I put hydroxide in parentheses. That tells me I have a calcium with 2 hydroxides bonded to it. Chromic acid. All right. Chromic acid does not have hydro out front. So that tells me right away it's an oxy acid. Ic tells me that I have an 8 ending. So I know I'm going to have chrome, and then instead of ic, it's going to say 8. So I would need to look up on my table what chromate is. Chromate is CrO4 minus 2. It's an acid, so it has hydrogen out front. So that's plus 1. So I cross my charges. 2, 1. I have 2 H's and 1 chromate ion. And there it is. All right, I'm going to get rid of some of this scratch work. Let's look at phosphorus acid. Okay, same thought process here. Hydro is not out front, so it must be an oxy acid. So I know I've got a polyatomic ion. I've got OUS. OUS equals ite. All right, that's where it came from. So I know phosphate is PO4, so I must have PO3. My charge doesn't change, so it's still a PO3 minus 3, just like phosphate is PO4 minus 3. H is plus 1, so my 3 is going to come down, and my 1 is going to come down. So H3, PO3, phosphorus acid. All right, let's look at acetic acid. Same thought process, right? No hydro, so I must have an oxy acid. Ic came from 8, right? So I've got not acetic, but I have acetate. All right, that would be the compound that I'm looking up. Acetate is C2H3O2, and it has a negative 1 charge. Hydrogen goes out front, positive 1, so nothing changes. So HC2H3O2. And we'll talk more about acetic acid later on. Acetic acid is pretty common. Last one, hydroselenic acid. All right, I see hydro. I know there's an H out front. Plus 1. I know selenic must be the element selenium. So I look up selenium, which is Se. I find that Se is a chalcogen. It's in the minus 2 group. So cross my charges, H2Se. And that's it, okay? So when we are looking at naming acids, or naming bases, this is how we go about it, all right? This will get us started. Make sure that you are looking at the polyatomic ions. Make sure you're using the cross-charge method. If you have any questions, let me know. I'd be glad to give you guys a hand.